So yeah, without further ado, I'm going to introduce our speaker today. We're so excited to have him here. We're welcoming Cuauhtemoc Villa, and Cuauhtemoc has like an incredible wealth of experience. So I'm going to kind of give you a little bit of his background before he jumps in to share the mysteries of microbes and soil and water today. So Cuauhtemoc is a Bokashi and Biochar educator, consultant. He's a restoration technician with Sound Native Plants, restores ecosystems, focuses on permaculture and food sovereignty. He's been teaching youth and adult education on these topics for years, and he focuses on how to improve and maintain very productive soil. So he's also a very talented teacher and educator, and he's worked with young people as well as adults, and he merges Indigenous knowledge with modern techniques. So we're really excited to have him on today. So what's going to happen next is he's going to take it over here. And while you're in the middle of this webinar, if you have questions, please go ahead and put them in the Q&A. At the end, we're going to share those with Cuauhtemoc, and he's going to be able to answer those with you. So yeah, Cuauhtemoc, take it from here.
All right. Well, thanks for having me, Johnson Creek Watershed. It's great to talk to everybody about water and about microbes and about biochar. Anytime I get the opportunity, I jump right into it. But I wanted to first honor this portion of the talk to the watershed, all the rivers and creeks and streams that are doing all that work, that we're going to discover how important they are in the system. I want to honor them for a minute, but also dedicate this talk and this opportunity to the Wapato people. And we want to live in hope that one day the longhouse songs and the dances return back to Wapato Island. That's kind of our goal as we do this work, to bring back the stories of the indigenous microbes and the stories of the indigenous people, to build the ecology that was in such balance when these stories and dances were told. So I want to take a minute to reflect that and give thanks for that. But as we start our journey, we're going to look back before we can even learn about the watershed, and we're going to look at what our planet was like when it was in a young stage. And Earth's first inhabitants, those first early indigenous microbes, they had a rough scene going on. It was very hot, it was toxic. We had very unfavorable conditions by today's standard, very little oxygen, methane gases, nitrogen gases, all the things we look at today in restoration as a problem. There was a group of indigenous microbes that were very happy doing the work here. And as a byproduct from their existence, they created gases that we know as oxygen. And they would consume a lot of toxic things and then leave building blocks behind, folic acids, amino acids, all these things that other life we know today are required. But back then, it was a gift that the indigenous microbes provided as they converted this planet. They haven't left though. If we looked around, we can still find them probably in areas where we're not going to find too much other life. You know, they're very happy in volcanoes. In soil, of course, we know that they're there, but they fly also through the air, and they're in the watershed. They take on to the watershed, and this is a big part of their existence. The microbes, as I went from the very toxic microbes that I spoke about to the microbes we know now today, very different. Those groups, two different groups of microbes, they learned to work together, and in doing so, they created quite a playground. And this symbiosis that we know is called Mother Earth. You know, what we see today is the work of all these different microbes taking place and doing all of their good work in their conversion. This is part of the evolution that we have here on Earth going on. Most of our Earth is covered in water. Water and ice provide a safe place for microbes, and they seem to recharge themselves in the mineral-rich waters of the ocean and in the streams. And when they're recharged, they're able to continue to do their regenerative work. So the watershed is a natural contributor for the movement of microbes, as the watershed collects vital nutrients and carbon that then regenerate these indigenous microbes to continue to work and build and do their sustainable work that we know today and strive so hard for an ecological restoration. Typically, we can tell an environment and how healthy it is based on the watershed. When the watersheds are balanced and the microbials are in balance, then we also have the land around it representing that. You know, if you can think of your own health, it's very similar to that. When your gut's in balance, usually everything else is in balance. So the watershed is a very important part of maintaining the whole ecosystem. We have, as the plants and trees begin to move out of the watershed, it's very representative at each level of the work that they're doing. You know, specifically, we see the sedges and grasses first, but there's a special partnership that's taken place between certain microbes and the plants and trees. But due to declining population of these microorganisms due to human pollution, it affects the health of the water. And then this directly affects the health of the plants and trees and the surrounding ecosystem around it. So we need to think about how nature has worked over time, from going from a toxic planet to a rich planet full of life. And think about the relationships below the soil and the contributors and the movers of those microorganisms, the watershed. You know, currently we're doing a lot of restoration on watersheds using native plants and trees. Stormwater facilities are making a great impact on the river systems. But what if we thought for a minute about repartnering up with these microorganisms, these indigenous microbes, to help those plants thrive, to restore the water system? Well, I thought about that, and I conducted a little experiment. We have our first poll coming up today. How many microbes do you think are in a gram of soil? Go ahead and answer that poll, and we'll see what your answers are. And we'll get back to you in a minute on that. But I conducted an experiment to see what it'd be like to add microorganisms to a watershed. Now, the microorganisms that I added to the watershed are some that you know are familiar with, that you have in probiotics. The lactic acid bacteria that we know in olives, they have an ability to keep things from spoiling. They keep things really clean. So I've enlisted the lactic acid bacteria for that. We also know that lactic acid bacteria from converting milk into cheese. So this, what we refer to as labs for short, was part of the microbes that I conducted this experiment with. Also, I used things like yeast that we know from making bread and making beer and wine. Yeast has the ability to digest a lot of organic matter quickly. So to make things bioavailable, I enlisted the yeast for that. And then the third microbe I enlisted is one that lives in the belly of the worm, and it's called purple non-sulfur bacteria. They also use it for food industry to make Swiss cheese. It's very gassy. It gasses off a lot of oxygen as it converts CO2 and carbohydrates. And that's why we get the big holes in the Swiss cheese. But it's able to convert oxygen, made it very attractive for me. What probiotics do any of you currently take? We've got another poll up today, a few options. I'm interested to see what you're taking for your own gut health in relation to what we're doing for ecological restoration. So go ahead and answer that poll. And then we have this consortium of microbes that are lactic acid, yeast, and then purple non-sulfur bacteria, which we know from the belly of the worm. It's actually my personal favorite microbe. I would grab these little microorganisms, and ball them up together in mud. And the mud contains its own unique indigenous microorganisms specific for each land. So when I would have these indigenous microorganisms, and they would meet this probiotic that I put in, and we refer to the probiotic as EM, effective microbes, they would then begin to converse. And the EM has a strong capacity for working with indigenous microbes and not actually taking them over, but coexisting to build a community. So here we'll take all the mud from the native site in which we want to do bioremediation. And then I would take the probiotic liquid and mix it with the mud, so that a meeting of sort would take place in the mud ball, so that the good microbes can talk to the mud from the area I'm trying to bioremediate, and then they would begin to communicate. Microbes have a very unique form of communication. They're the first ones who had cellular communication, the way that they communicate to each other. So in that mud ball, you're seeing the activity and they're gonna start to relate and then communicate how to make that area more symbiosis. And the EM probiotic microbes have a capacity so that when they go into nature, they don't take over. We have sites where the EM has been used a long time in Costa Rica, and you can take soil samples of the soil, and you can look for the three microbes, the labs, the yeast, and the purple non-sulfur bacteria, and you can't find them. And we're surprised by that because they use them every week for 15 years, But what we discovered was that the EM microbes actually become like a food source for the indigenous microbes for the area. It's like a catalyst. So it gets them, the indigenous microbes for that area, to begin to grow naturally and kickstart themselves back into where they need to be to bring balance for that area. So it's really interesting to see how these probiotics don't come to take over, but kind of like your body, just to work naturally with the area. So we had great results doing that. We would throw those mud balls into the Napa River, and it just great things would happen. So the indigenous microorganisms, we're finding that the USDA has the greatest success comparing them to things like the EM effective microbes or other probiotics. So nature really does have what it takes to restore, but we have to somehow foster the indigenous microbes for that area. So when the USDA put out their stories and their data about fostering indigenous microorganisms, they linked it with biochar. And biochar is a perfect home for these microorganisms that we need to be in the watershed and throughout the soil. When we think of a fire, we know that it usually grows better after a fire. The land is really just gets recharged after this. But we don't think about how the watershed also benefits from the carbon deposits being washed in by the runoff. The carbon remains from the trees. They hold a lot of data about the surrounding watershed. And it's similar to semiconductor technology. And the information is stored within the carbon, and it's passed on to the new biology systems. And that's why those trees are able to regrow so fast. So biochar, when we look at biochar, you can put it under a microscope and you'll see this honeycomb structure, which is just great for holding nutrients and water and nematodes and all kinds of things. It's like an apartment building for soil life. But what it also has is electricity. And this is like the key part where we're starting to learn about soil biology, but there's a new group of microbes that's coming onto the scene. And these are like electron-loving microorganisms. And these are the basis of the soil food web. And without electron-loving microbes, the rest of the food web can collapse. So the char allows for this electrical conductivity to take place. And there's so much information stored on the carbon structures of the char that without the biological information to guide the new ecology, life would be very challenging, as life would be for us if we didn't have our phones with semiconductor capacity to tell us when and where things are going on. So we really mimic our technology off of what nature does, and that's where we're at in developing a lot of the technology we have today. So the electron-loving microbes are, these are the new ones that we're looking for. These are the ones that we're fostering when we do our projects, when we are developing soil. We're missing these guys, and we got to kind of look at them. If we're thinking of doing the complete full spectrum restoration, we gotta partner with them. Yeah, so when we partner with them, we find balance. It's just restored naturally. We have to do less work, less human input is required when we can count on microorganisms to do the work for us and in the right place. So a lot of the workshops that I do teaching about all of this microorganisms and biochar currently is done at Nootka Farm Collective. We're out on Savi Island and Wapato Island. We are always accepting volunteers. We're open to all ages, but this is where you get your hands dirty. This is where you can actually learn how to use and apply a lot of the methods, biochar, the compost teas, the bokashi, all of the regenerative methods that are kind of being missed today by mainstream education. You can volunteer to come out to the farm and we'll teach you while you're there. I brought this to schools in the past, and this here is a video on YouTube. It's called Micro Power. And this shows how I always felt like teaching the kids about the microorganisms was going to be the best way to get this thing off the ground. In Napa, a lot of the kids were children of vineyard owners. So I knew that they would inherit the land down the line. So a lot of the bokashi ball making that you saw earlier, and all of these things were implemented in Napa and captured in the video. So you can get a taste of that and take a look at that. I do consulting on the side where watershed agencies, air quality boards, and other groups bring us in to educate. In this case, it's a vineyard where they're usually tear out their vineyards and they burn them and a bunch of smoke's created. But we come in and we teach them, see how he's lighting the fire from the top. This is a top burn method where they're able to utilize the biomass by lighting it at the top. A lot of the smoke gets trapped into the flame front. So there's zero smoke coming off the burn piles now. And in the past in Napa County, that's all you saw was smoke coming out of the burn piles. But by teaching ag and foresters how to convert large amounts of biomass at the top burn, they're able to reduce the smoke and then cool the smoke at a certain point where those IMO, indigenous microorganisms, can now be placed right onto the char immediately, and then also create a bunch of char in the process. So they're able to now to convert and utilize tons of waste material. And those are a little bit of what I'm doing here in Oregon, a little bit in California. Biocarbon Associates is a consulting outfit in which we teach you how to convert a lot of biomass. Nook and Farm Collective, if you wanted to come out for education or bring education out to your farm, you can reach us there. Or direct questions, reach me at Bokashi for you. And restoration conservation work can be contacted through Sound Native Plants.
Great. Thank you so much, Cuauhtemoc. We're really excited to be able to jump in with some Q&A. Am I interrupting any more presentation? Are you ready for some questions?
No, I like the question part. It's so hard to do the presentation. I'm used to just talking this stuff out.
You did great. Thank you so much.
Like watching a kid ride a bike. It's so hard to go through it on the slide.
Well, you did a great job. Thank you so much for sharing all that. So the first question we have is from John Marshall on Facebook. He says, as a wetland manager, he has an interest in gaining better understanding in the role of microbes in the redox process and saturated anaerobic soil, hydraulic soils. Hydric soils. So, the question is, can you please describe for me the roles of microorganisms and how they serve in this process?
Yes. In an anaerobic condition, the probiotic that I described to you, the EM, the purple non-sulfur bacteria, is what we're going to need, because as I described to you, we have this thing that loves the anaerobic condition, but it's gassing off oxygen. So it's going to start to convert the anaerobic back to aerobic, and then bring in those colonies to then complete the conversion. So that's what makes it so exciting with that purple non-sulfur bacteria. It feeds 4 different ways. It can live in very harsh conditions, and it just does its work, and it's creating oxygen, folic acids, amino acids. These are the things you need when you're trying to switch those kind of conditions around. So I would refer to the EM effective microbes and look at how that particular microbe plays in the anaerobic condition.
Thank you for that. We have one more question from David on Zoom, and he's asking, can electron-loving microbes be found in a soil sample?
Well, you would need a soil test for that. They've just discovered a lot of these guys. There's only about 5 or 6 of them that they have studies on. So to find a lab in which does this, you even just mentioned electron-loving microbes, and it's just like right over people's heads. So these are the kind of things where we don't know on the lab-wise on your current lab tests, but we'll get there. And if we provide the right environment, the char, these the PNSB, which is just kicking off electrons to all these other microbes that need them, you can see where that's kind of like that purple non-sulfur is almost like the bridge from the electron-loving microbes to the ones that we know currently today. But since we've done our study of this thing, kind of put the cart before the horse, we're just now finally getting into the microbe side of things. That should have been the first thing we were looking at when it comes to restoration, because this whole planet was based on the microbe activity. So these are the kind of things now we got to just kind of pull back for a minute. We have all the tools we need to look at it. And then now we can look at these relationships. And that's what's good about USDA, that they're trying to jump all over it now. And because they know that we missed something. And those missing links now are filling the gaps of the puzzle that what we need in restoration.
Great, thank you. So next question from Gail on Zoom. She wanted to ask if you could define biochar. You've used it in the talk, but we didn't go too much into detail on it. Okay,
so biochar would just be burnt wood, but when you refer to biochar now, it's classified as burnt wood with a certain amount of percentage of carbon within the material. And I believe it's about 65% carbon. A really good biochar would be up in the 80% carbon compounds. And that means a lot of the volatile gases have been burnt and excreted from the biomass. And if you go back to that slide that I had showed earlier, you can look at the holes. All of those holes traditionally, if that was charcoal that was going to be used for cooking, those holes would be filled. But since we took it at a higher temperature, the volatile gases came out and we have empty pots now. So what we're looking for is carbon with a lot of those holes in it, because I need housing. I need housing for these microbes. The more different holes and shapes I have, then the more I can accommodate the microorganism populations. So biochar, when I refer to biochar, it's burnt wood. And nature does this all the time. We're going through it right now. We're in a situation where we're watching nature create its own char. And it does this because this is how the planet lives.
Thank you so much for that. We've got another question right now from Jamie on Zoom. And she was asking if there's things people can do at home to put more EMs into our soil, like kombucha for our soil. That's a question.
Great question. And that's what makes the EM so cool. When I learned this thing 17 years ago, we were taught once you had yourself 1 quart of it, you then can take 1 quart of the EM liquid, 1 quart of molasses or sugar source, and then 20 parts water. And you would brew that in an anaerobic condition. Since you have microbes in there that are creating oxygen and some creating CO2, it's just like a whole world in there. So you can take quarts of this EM once you have it, and you can brew it yourself. And then once you brew it yourself, you made, from 1 quart, you're making 20 parts water. You'd have 5 gallons of EM. You can pass that around to a lot of people. So when we first learned it, it was taught so that it came from third world countries where people didn't have access to farm fertilizers and things like that. So you had to show people how to grow the culture so then they can then use this culture to convert organic matter, which then can be used for the farm. Because if you pitch these microbes on organic matter, it's then going to be bioavailable super quickly. And this then means that you can grow your crops and get better crops that way. So that's the whole point, is to learn. It's like a sourdough bread. Once you have the thing, it goes forever. The batch I have is 17 years old. I've been growing it for so long. I use water from different watersheds that I feel are just pristine. It's collecting indigenous microbes from those watersheds. But when people use the EM that I've been brewing for so long, and they use other standard EMs, you can tell it's made different. It becomes part of you. And that's what makes it so unique, because when you're in these special places and the ecology's right, you can then enlist and then grab a little bit of water, or maybe grab a little bit of that dirt that it's in that magic place, and in that dirt has those organisms that then you can culture. So learning the culture, learning the simple, in our American culture, we don't do a lot of fermentation, but where this comes from in Japan, it's part of the culture. And so when you incorporate it into certain areas of the world, it's very natural. But American culture, we get our food packaged everywhere, so we don't get that as much. But go back to the roots, start fermenting things again, making bread, making yogurt, making kombucha, and you'll realize this is like right in line. Once I have the EM microbes, then you can then do so many things specific for each site that way.
Thank you. Yeah, we've got a lot of great questions coming in. So the next one I just saw was, this question is just kind of about your educational experience, from Annie on Facebook. She wanted to know and hear more about what it's like sharing this knowledge and research with young people.
It's the best thing. No, really, it's the best thing that's ever happened. We have one story where one boy, he was autistic, and he hasn't talked in 2.5 years. And I was in the garden class. I was like my fourth time doing a class with this particular group. I was there once a week with this group. And in the middle of one of the games, Gianapollo is his name. I love you, boy. Gianapollo spoke. And the whole class never heard him speak before. Everyone stopped the game, and each child individually hugged Gianapollo. This made me start to really look at what happens when we're in the soil. And then come to find out down the line, a lot of us are writing soil grants, but if the Mental Health Institute actually has a lot of money for garden programs, but you have to write your grant so that you can show them that the kids are gonna have their hands in dirt. Do you see those mud balls? That's a guarantee. So because what happens is Mental Health Institute knows there's a microbe in soil that once you touch it, it releases serotonin in the brain and it makes you feel good. I believe it's 100%. Gianapolo knows we were going to get dirty, and he liked that part of the class, and he was comfortable enough to talk. So these areas of neurobiology, soil microorganisms, autistic kids, there's no stopping now. Teaching kids is what the main thing I want to do. They get it. They get it. The look on their face when you're telling them, they don't forget it, and it's how we live. So if you need any help on that, direct contact on there. You let me know how I can help.
Yeah, thank you for sharing that. So yeah, our next question is from Lloyd from Facebook, and he wants to know, does a commercial lacto yeast cyano formula of Bokashi starter meet the standards of your probiotic formula? And on the composting aside, what sort of direct application of Bokashi would you recommend regarding after harvest soil beds?
Okay.
Kind of a specific question.
Okay. So then the labs, if you buy labs by themselves, they can work, but they've only been grown with their own culture, and microbes have their own language. So if you're only growing with your own language the whole time, it's going to make it difficult when they go into the community of microorganisms and try to coexist. That's what makes the labs very special in the EM culture, is because they're growing both with anaerobic, aerobic. Traditionally, we don't mix the two together, but most of all, they're learning the ways of a lot of different cultures that they're going to face within the soil, which gives them a greater chance of survival. So the labs you buy in isolation are a little bit more difficult for success. That's not to say they can't do the right thing once you get them going and brewing, but I just would rather use a group of cultures that's very versed in many languages so that they can partner up with the right team once they go into the soil. Once I clear out a garden bed, I usually drop in anywhere between, you can go about a gallon of Bokashi per 100 feet in the fall. Granted, you leave some biomass down on the ground, and then the rains and everything should get those microbes to grow. These microbes in the right condition will self-divide and grow every 20 minutes. So if we can just provide them, drop it down, maybe even throw straw or some kind of cover up on top of them, and let nature do its thing, just like the trees. No one's out there in the forest taking care of the trees, but the leaves fall. The leaves fall and the microbes continue to consume the organic matter, and this allows them to thrive. And then, so yeah, add cover to your beds, and you should get to where you want to be.
That's great. Thank you so much for getting into depth on that question. Our next question is from Risa. Can you talk more about where to get these microbes? So maybe this is specifically, where to purchase them or things like that.
Good question, because there's a lot of stuff out there. The two companies that I trust for microorganism is going to be Terraganics. Terraganics sells EM effective microbes. They do such a good job, and they're the original people who brought it here. Then there's a second company called SCD Probiotics. He's a student of Terraganics and just maintains the quality, but puts a little bit of a different spin on it that makes it his own. And those are the two companies. I wouldn't buy other effective microbe probiotics to achieve the things in which I'm telling you. Those two companies there seem like they have it. And then you can find specific formulas within those companies if you're doing something where you want more of the purple non-sulfur bacteria, more of the electron-loving microbes. SCD Probiotics has a consortia that's really high in PNSB. And then they have some, for livestock. If you want to feed it to livestock, then the labs are a little bit higher. But you can really hone in your probiotic delivery with those two companies for your specific needs. So I would use those two. Mm-hmm.
That's great. Yeah, thank you. It's good to know actually where to go to purchase. So the next question is specifically kind of about water and microbes. So would the recommendation be to keep EM as far from a water body as traditional activities? It's kind of an interesting one to think about, the connection with water.
Yeah, well, all of these are food grade microbes. So it actually makes sense to put it closer to the bodies. All these are things that you would consume naturally. When you have infected bodies of water, that especially that are having ill effects on people, this is what you want in the water. There's nothing in the effective microorganisms that's scary other than the name microorganisms. You eat these things every day. They're in the air. They're on the skin of grapes, and they're all around you. So they don't harm people at all. They're good for people.
Yeah, that's great. Thank you so much for getting into that. That's a good question to kind of get to. I'm excited to hear that. So the next one is from Rob on Zoom. As he said, is the use of electron-loving microbes scalable for mass CO2 capture? Just reading a Science Daily article describing these events.
No, I love that question because Matt Wood, who owns SCD Probiotics, he's coined by the owner of the EM company. And Matt Wood one time said that, well, what if we put it on the back of airplanes? Can we spray it down on top of it and consume the CO2 back to oxygen? Now, I believe that every time I set a garden up and set these fields up with these microbials in place, they're pulling down that CO2 and they're gassing up the oxygen. We're creating bioremediation fields. Absolutely 100%. That's what they did in the beginning. That's what they want to continue to do now. So I love your thinking, and this is exactly why I wanted to do talks like this. That's how we reverse the CO2 climate change. How we get it there, I don't know. The airplane thing might be a bit much, but definitely start by getting in the soil so it can breathe it down, get it in, and then we begin to have that respiratory system of the planet happening. And I think that's really the only way out of this thing is she got to breathe again. So could happen. Yeah.
So true. Yeah. So the next question, I'm going to kind of condense this a little bit. This is from Gracie on Zoom. She's asking some questions about her home. And she says below the edge of her backyard, there's a stream that used to have lots of frogs. And now for years, there's been no more frogs. And she wants to know if there's an organization or company up here in Western Washington, or even from Oregon or elsewhere, with whom she could consult with to see if anything can be done to discover why they're gone and find a way to bring the stream back to a healthy environment for frogs to thrive. It's a great question.
Yeah, those are indicator species. We don't see the frogs. She's worried, and she should be. And these are the first things when we start to use the EM and the Bokashi. If you just started using it around your place, these are the first critters that come back. You see the frogs. If it's a dry place, the lizards come back. And then the worms, you see worms start showing up. I love to, when I come to a field and evaluate, I dig into the ground and I look for worms, but I look for these indicator species that we call them. So then I can tell, like, all right, well, this guy's already got a ton of frogs. Then I know a different approach to use on his environment looks pretty good. But if I'm not seeing frogs, if there's no lizards and there's no worms, there's no microorganism. That place is sick. So what I would do is, yeah, you definitely want to start building the ecology somehow around your property. You can contact us at Biocarbon Associates. We'd be happy to come down and take a look at what you got going on. But you know, this might be a bigger job, something upstream from you. So these are the things, we're getting them information out to people so they can begin to do something on their land. And then the agencies can then begin to write the grants and permits so that the landowners can act a little quicker for biomass conversions, for microbial inoculations. Then this is where the watershed can really benefit from partnering up with those neighbors on the creek lines who are ready to take action and ready to do something, because what we're doing is not working fast enough. So thank you so much for opening that door.
Very true. Also, just throwing out there, some other folks have mentioned this too. You can also work with local watershed or conservation districts, depending on your area that you're in, Gracie. One other great question we have from a user, someone just said, this is such an amazing talk. Do you have a book or more resources where folks can keep learning what you teach?
Yeah, and a book is coming online. I have an online course through Matt Powers, the advanced permaculture student. Matt Powers has just been on me to do a book and get something out there. And I started to put the thing together. The last couple months, things have been kind of unwinding. But thank you for encouraging me to stay on that. We need to get this information out. And whether it's completely got it all or not, we need to get bits and pieces out so we can encourage students, grad students, and other agencies to then grab pieces of this thing and move forward on it. I know that's the reason why I do this. I'm the early stages of this thing. I'm the worst example of it. But I know the more people I teach about it, the next group of people coming in, man, you guys are the ones that are going to take it further. I can hardly get my computer up to do what I'm doing now, but you guys have the skills required to bring it to everybody else. So that's what I want to do, is be that link to give you guys the information, so then you can then put it into the technical format so it can reach the ears. But book coming soon for sure. Teamwork with everybody so we can get the information out. Thank you.
Very true. Also, a quick note, right now on the screen, you've got some links for consulting with Cuauhtemoc, and also Sound Native Plants, additional information there too. And I'm also going to send out an email to you if you're registered on Zoom, and if you're on Facebook, I'll put it in the comments, links, how to get in touch with Cuauhtemoc and how to find out more. One more question, and if you have final questions now, you can send them in right now, but here's one I have up. Someone wants to know, they're curious how Sound Natives and others are applying this in upland restoration practices.
So the discussion's out. We're doing irrigation now in stormwater facilities. And I talked with City of Portland people and the managers of our company on how to integrate this technology and into the system. And a lot of the hiccups that we have is when we talk about compost and compost tea is the managements are, they know that the stormwater systems are overloaded with nutrient loads. But what they don't realize is the microorganisms are not a nutrient load at all. It's actually a nutrient digester. So having those conversations now, we need to have those doors open up so that we can show them, you know, this is not compost tea. It's called compost tea. You can call it compost tea, but it's really a probiotic. It's like giving the bioswale yogurt or kefir on a regular. If we don't drink these things on a regular, we get upset tummies. Swales are no different. So getting them to understand the microbial digestion is very similar to their digestion in the stormwater facilities. Then it's going right in. So the conversations now are being had. This year, since I worked irrigation, I really got a chance to look at how to get the microbes into a system that we currently use, because you can't reinvent the wheel. So we have a few approaches that I'm ready to, with the planting and the restoration work that we're doing and the irrigation, we can really begin to do some amazing things at the microbial level based on the tools that we have now. So we're getting there. We're getting there so close.
It looks like right now we've kind of wrapped up our question sections. We've got a lot of people who are just saying thank you, that you're knowledgeable, and really excited to be working with you. So I just wanted to give a big shout out to Cuauhtemoc, and also just the time that he spent putting into this presentation in the midst of the wildfires and everything going on right now. And I know it's affecting many people's homes. So thank you so much for tuning in. Just a reminder, if you're curious about consultants, Cuauhtemoc does consulting. He works with Nook Farms. He works with Sound Native Plants. So many different ways to work with him in the future. I'm going to provide those links to you in the comments on Facebook. If you signed up on Zoom, I'll be sending out an email tomorrow with a link to the recording that's going to go on YouTube. So this recording will be out and available for you to share with others, in addition to on Facebook too. So I just wanted to say thank you so much for tuning in. Thank you so much, Cuauhtemoc, and for joining us today. This has been so great to have you on. I've learned so much just through this process, listening to the webinar, reading people's questions. So thanks so much. Appreciate you. Do you have any last things you want to share with us?
Yeah, thank you. Big up to you, Tiffany. That's so brave of you to bring this on as a platform the way that you did. It shows innovation and it shows character. I love what you've done. Thank you so much for today and helping me through this. You know what a mess I am on this computer. You know firsthand more than anybody. So thank you so much.
You're doing great. Thank you so much. Appreciate it, everyone. Have a great day. We're just going to close this up and you will see the recording up tomorrow. If you're on Facebook, the recording is going to be there as soon as this ends. And yeah, we look forward to seeing you on more community education series. Stay tuned on our Facebook page, Instagram, and our website at jcwc.org. We'll be posting new opportunities to get engaged with us, both in person and virtually. Thank you so much for joining today. We have lots of people, Cuauhtemoc right now, saying thank you and they appreciate your time. So big thanks, and I hope you have a good week and hope everyone stays safe out there. Thank you.
Yes, thank you guys. Bye-bye.